That one just went off. He's like, I'm gonna go off because I want to. All right, so let's try one more here. Actually, let's do this. Well, let's try one more of these z-scores, and then I'll do an extra little piece, and then we'll call it a day. See what you guys think about this. So draw the picture, shade in the area, try to look it up. Even before you do anything, you know your final answer should be very, very small, right? So it's a nice check. So people don't just go, well, that's what the chart said. Well, you should know ahead of time about what it should be. You should be able to tell when you made a big mistake. Does the chart get a little weird for this problem? You guys see what's happening? This is where me and the chart disagree a little bit, so you can do it either way. It says the minute you get up to 3.5, it's 0.9999 always. 999, yes. That's bullshit, to be really honest. Nothing against the chart. I kind of understand what they mean. But if I'm up as a z-score of 10, are you guys at the point where you realize that is like a holy, holy, holy shit z-score? 10 standard deviations above the mean. That would be the 28-foot dude, roughly, I don't know, right? His height, z-score is 10. Holy shit! What happened? Where did he come from? Maybe. 3.57 is pretty damn big, too. Holy shit. So this chart says it's always 0.999. What I would say is anything above 3.5, I would say approximately 100%. So but you can use the chart if you want to. I don't care. You can use that number. I love it. So where's 0.9999 go? Yeah, always below. Oh, damn, Jeff, don't look up there. Right? Always below the number you just looked up, because that's the only thing the chart knows. So, of course, what's the answer going to be? Yeah. So I would say this was approximately 100%, so I'd say the answer is approximately 0%. Either way, especially when you get to like 5, 6, 7 z-score, it's not 0.9999 here, it's 0.9999999. And most people will just go, damn, that's basically going to happen. Maybe. All right, so last little thing. This is all nice and good if I'm dealing with z-scores. So what if I had this? Okay, what if I had a normal distribution? Okay, that I got to tell you, right? Otherwise I can't use the z-score. And I know the mean is, what you got, Jeff? 18. And I know the standard deviation is, make something up. There you go, buddy. Look at that shit happen. All right, 2.09. You with me? And I want to know the probability. So this is ages of people in a place. There you go, Jeff. Very creative. And I want to know the probability that somebody I pick is older than 21. Yes? You guys understand everything? What's going to be in the middle of the picture when I make it now? It's not going to be 0. It's going to be 18. Oh, it's always the mean in the middle, right? So if I have z-scores, the mean will be 0. Whatever the hell it is, so z-score will be 0. Do I have z-scores right now? Nope. I got what's known as raw scores. They haven't been processed yet. So first try to draw this picture, right? 18's in the middle. You should know where 21 goes. Shade in the area of what I want. And then we'll talk about what to do next, because this chart only works with z-scores. know it's normal, so I can draw that. In the middle, I'm going to put 18. Where's 21 go? Up here somewhere. Is that cool? And where am I going to shade? Yes, okay, I see. Right, above 21. So what the hell do I do from here? I know it's normal, so I should be able to use a chart, but the chart only understands z-scores. Do I have a formula to convert x-scores into z? That's why we call this a raw score. It hasn't been processed yet. Do I have a z machine to process this shit? Yes. So I can use z equals x minus the mean divided by the standard deviation. And then it becomes a problem like we were just doing. The minute I make z-scores out of this, it becomes a problem like we were just doing. So figure out what that z-score is. What's x in this case? Yeah, 21. It's the score that I'm interested in minus the mean divided by the standard deviation. 1.46. I don't know. I just making shit up. I know.
1.4. Do we round up?
I don't know. What is it? Yeah.
Well,
now think about it.
it's 1.435.
1.435, blah, blah, blah?
Yeah.
Okay. How many places do you think we have to round z-scores? How far does the chart go?
4.
There you z-scores. 2. You with me? So you can round everything in this class to 4 places, and that covers you with all my little rules, right? But z-scores, obviously, you round to 2 places, because that's as far as the chart goes. Now, just a quick word about that, in case anybody's taken stats before, and you're going to come at me with, well, my teacher lets us push buttons on the calculator, and I get all kinds of shit, and it's better than that. No, I don't give a shit, right? The reason I'm cool with, I really want you to understand, if a z-score was, I'm going to round it, which means my answer is going to be off a little bit. Does that make sense? If I round it a little bit, my answer is going to be off. I'm completely cool with that, because you're learning ideas here. In the real world, you can use whatever software package, whatever your company wants you to use, and it can get out to the 20 millionth place. That's good for it. I don't give a shit. Using the chart helps us learn the idea. So if you wanted to say something about your past teacher pushing buttons, don't, because that's a button for me for you to push. Don't do that. Okay. What do you got? I'm sorry. What was it again? 2 point. No. 1. I said it earlier. I forgot. 1.44.
Yeah.
So 1.44. Yeah. So yeah, truly round it. And now it's so. Watch this. Under 18, I'm going to put 0 in parentheses. So just under the x-score, I'm going to put the z-score. The mean always becomes 0 because the z-score is how far from the mean you are. What am I going to put under 21? Holy shit. And then I just look that up and I do what we were just doing. So if I have x's and I know it's a normal curve, I make the x's into z's, and then it's the same problems we were just doing. Isn't that crazy? So look up 1.44. So what do you, yeah, go ahead. What do you get for 1.44? 0.9251, yep. So that's down here, of course. So the actual answer is going to be 0.0749. Just 1 minus 0.9251, right? To get the other side. Is that right? And of course, if you like the shortcut, you look up negative 1.44 and you get 0.0749 directly. I saved like 2.5 seconds. Ooh. Still, yeah, it's a nice shortcut. Maybe. This is unbelievably useful if I know something's normally distributed. And more things are than we think. Heights are normally distributed. Weights are normally distributed. A lot of these physical characteristics of some organism, are normally distributed, because most of us will be in the middle, and then some people have genes that make them really tall, and some other people have things that make them really short, but not nearly as many. So that's why it does come out to be a nice normal curve. It's crazy. IQ scores are normal, but that's kind of boring because we force them to be normal. We kind of just make them normal. You're way down here, and you're like, you made that thing up. Oh, okay. Right, so I don't know if you guys know that. All right. Maybe. What do you guys think? What time is it? That's plenty for today, right? What do you think? Mm-hmm. Is that all right? Anybody upset if I let you out early? I love you guys. You can't even say okay to that. Shit. I did have somebody get offended one time. I paid for this shit. What are you doing, Lee?